Welcome back, everyone. We're about to take a deep dive into the world of pipeline safety. But trust me, it's way more important than most people realize. And today, we're going to be talking about something that's been borrowed from another high-stakes industry, one that's all about preventing catastrophic failures, nuclear power.
Preventing meltdowns. Okay, I'm intrigued.
Right. So we're not just talking about like routine inspections or anything like that. This is about a technique called Probabilistic Risk Analysis, or PRA for short. And it's basically a way of figuring out all the things that could go wrong, even the really, really unlikely stuff. By understanding all the possibilities, we can make smarter decisions about where to focus our resources.
I see. So it's not just about fixing the obvious problems, it's about anticipating what could happen and preventing it.
Exactly. And the whole idea of PRA actually came from those massive nuclear reactors back in the 1970s. And the nuclear industry was under a lot of pressure to prove that their plants were safe. That they weren't going to melt down and cause a major disaster. They needed a way to analyze risk that went beyond just checking off boxes.
So what did they come up with?
Well, they came up with something called fault tree analysis. Imagine a giant flowchart, but instead of mapping out a process, you're mapping out all the different ways a system could fail. You start with a worst-case scenario, like a pipeline rupture, and then work backwards, figuring out all the events that could lead to that failure.
Like a detective working in reverse, finding the clues.
They were modeling potential nuclear accidents, and it was mind-blowing stuff. It totally changed the way people thought about risk. It wasn't just about preventing the most obvious failures. It was about understanding the whole spectrum of possibilities.
So they were basically saying, hey, we know things can go wrong even if we can't always predict exactly what or when.
Exactly. And instead of pretending that we have all the answers, we use probability to model different outcomes, and that gives us a much more realistic picture of the risks we're dealing with.
So the probabilistic part of PRA comes from using probability to model different outcomes.
You got it. So instead of asking, will this pipeline fail? We ask, what is the probability of this pipeline failing under these specific conditions? And that's a really important shift in thinking because it acknowledges that there's always some level of uncertainty. And that brings us to a really cool example of how PRA is being used in the real world. A system called TRIAGE, developed by a company called AbaData, specifically for upstream oil and gas pipelines. It's about prioritizing. But what makes TRIAGE so fascinating is that it was the first system to really consider the impact of upstream well behavior on pipeline risk.
Wait, so it's not just about the pipeline itself, it's about what's happening at the wells that are feeding into it.
Exactly. Because it turns out that what's going on upstream can have a huge impact on the likelihood of pipeline failures. And TRIAGE uses some really advanced data analytics to uncover those hidden relationships. And one of the biggest things that TRIAGE discovered was a strong link between, startup behavior and corrosion in pipeline. It's a major cause of pipeline failures. So figuring out how something as seemingly simple as startup behavior can contribute to that problem is a big deal.
So TRIAGE can help operators prevent corrosion by analyzing startup behavior.
Exactly. It's all about shifting from a reactive approach, where we wait for something to break, to a proactive approach where we use data to anticipate problems and prevent them from happening in the first place.
Okay, I'm starting to see the power of this PRA thing. But I guess the big question is, how do pipeline operators actually use this PRA stuff to make their pipelines safer?
Well, that's where things get really interesting. The next step is to actually build what's called a fault tree. It's basically a visual representation of all the different ways a pipeline could fail. You start with that worst-case scenario, like a rupture, and then work backwards, identifying all the events that could lead to that failure. And by systematically working through all these different scenarios, you can start to see which parts of the system are the most critical and where the biggest weaknesses might be.
I see. So it's not just about the pipeline itself, it's about all the factors that could contribute to a failure, both inside and outside the pipeline.
You got it. And that's one of the things that makes TRIAGE so powerful. It doesn't just look at the pipeline in isolation. It considers all those upstream factors, like how the wells are being operated.
Right, because that can affect things like corrosion, which we talked about earlier.
Exactly. So TRIAGE is adding a whole new layer of information to that fault tree, making it even more comprehensive.
Okay, so you've got the data, you've built the fault tree, now what?
Well, now it's time to create the actual PRA model. And this is where things get really technical, because you're taking all that qualitative information from the fault tree and turning it into quantitative risk assessments.
So instead of just saying, this could happen, you're saying this has a 1 in 10,000 chance of happening.
Exactly. You're putting numbers to it. And that level of precision is what makes PRA so valuable. It gives you a way to compare different risks, prioritize your efforts, and justify your decisions to regulators. And the best part is that the PRA model isn't static. It's a living document that you can update as new information becomes available. It's about continuously monitoring, analyzing, and adapting to keep those pipelines safe.
Wow, this PRA stuff is pretty impressive. But I imagine building these models can get pretty complicated, especially for those massive pipeline networks.
Yeah, no doubt. It can be a pretty complex process. But luckily, there are software tools out there that can help make it a little bit easier.
But even with all these fancy tools, there must be some challenges to implementing PRA, right?
Oh, absolutely. There are definitely challenges. I mean, for starters, data availability can be a big one.
How so?
Well, like we talked about earlier, PRA models rely on data, right? Lots of data. And if that data is incomplete, inaccurate, or hard to access, it could really throw a wrench in the whole process. And then there's the challenge of expertise. I mean, PRA is a pretty specialized field, right? It requires a deep understanding of risk assessment, statistics, and pipeline engineering. And even when you have the right people, there's the challenge of staying up to date with the latest advancements in PRA. It's a constantly evolving field.
So it's not just a one-time learning thing, it's an ongoing process.
For sure. And then there's the human element, which can be the trickiest part of all.
The human element. What do you mean by that?
Well, PRA requires a shift in mindset, right? It's about moving from a reactive approach to a proactive approach. And that could be tough for some organizations, especially those that are used to doing things a certain way.
Right. People can be resistant to change.
Exactly. And so to make PRA really work, you need to get everyone on board. You need buy-in from leadership, from engineers, from operators, from everyone.
So it's about changing the culture, creating a safety-first environment.
Exactly. It's about building a culture where everyone understands the importance of risk and takes proactive steps to manage it.
That makes sense. But I'm sure there are some people who see PRA as just another bureaucratic hurdle, more paperwork and red tape. How do you convince them that it's actually worth the effort?
Yeah, that's a good point. I think the key is to focus on the benefits. And there are a lot of them, both tangible and intangible.
Okay, like what?
Well, for starters, PRA has been shown to reduce incidents. By identifying potential risks early on, operators can take steps to mitigate those risks before they turn into actual problems.
So it's like an ounce of prevention is worth a pound of cure.
Exactly. And by preventing incidents, you're also saving money, avoiding costly repairs, environmental damage, and disruptions to service.
Right, because those incidents can be incredibly expensive.
They can be. And PRA can also help optimize maintenance operations, too.
How so?
Well, by identifying those most critical assets and components, PRA models can help prioritize maintenance activities so you're focusing your resources where they'll have the biggest impact.
So instead of just doing routine maintenance on everything, you're targeting your efforts where they matter most.
Exactly. And that can save a lot of money, too.
That's smart. So it's not just about preventing accidents, it's about being more efficient with maintenance and resources.
Yeah, precisely. And then there's the whole communication and collaboration aspect.
What do you mean?
Well, to develop a good PRA model, you need input from a lot of different people, right? Engineers, operators, environmental experts, risk managers. So it forces everyone to work together, share their knowledge, and break down those silos that can sometimes exist within organizations.
I see. So it's a team effort.
Absolutely. And that improved communication can lead to better decision-making, faster response times, and a more proactive safety culture overall.
Wow. So PRA can have a ripple effect, impacting not just the pipeline itself, but the entire organization.
You got it. It's really about creating a culture of safety that permeates every level of the company. So we've talked about the benefits, the challenges, but what's next for PRA? Where do we go from here?
Well, I think one of the most exciting areas is how we can use AI, artificial intelligence, to make PRA even more powerful.
AI and pipelines, that sounds pretty futuristic.
It is. Imagine algorithms that can analyze mountains of data, way more than a human could ever handle, and spot patterns that we might miss.
So it's like having a super smart computer constantly looking for potential problems.
Yeah, exactly. These AI systems can help us anticipate problems before they even happen, optimize those maintenance schedules, and make much more informed decisions about the whole pipeline.
That's incredible. It really feels like we're on the verge of a big breakthrough in pipeline safety.
I think so too. And another thing that's really exciting is how we're starting to integrate PRA with other technologies, like geographic information systems or GIS.
GIS. I know those are used for mapping,
Yeah.
right?
So imagine a digital map that shows you the risk profile of every single inch of your pipeline in real time.
Wow, that would be amazing. You could see exactly where the high-risk areas are.
Exactly. You could track how effective your mitigation efforts are and even simulate what would happen in different scenarios. It's like having a crystal ball for pipeline safety.
That's a great analogy.
Yeah.
And you mentioned integrating PRA with other systems too, like asset management systems.
Yeah. And that can help you streamline maintenance, make sure you're using your resources effectively, and ultimately extend the life of your pipeline assets.
So it's not just about preventing accidents, it's about managing the entire life cycle of the pipeline with safety and efficiency in mind.
Exactly. And all of that's powered by the data-driven insights we get from PRA. It's really a game changer.
Well, I have to say, after learning all about PRA, I'm feeling pretty optimistic about the future of pipeline safety. It seems like we're heading in the right direction.
I agree. We have the tools, the technology, the knowledge to make pipelines safer than they've ever been.
But it's not just about the technology, right? It's about the people too.
Absolutely. We need skilled engineers, we need proactive operators, and we need a culture of safety at every level of the organization.
And we need leaders who are willing to embrace these new ideas, invest in training, and really champion this data-driven approach to risk. PRA isn't just a technical exercise. It's a journey. It's about constantly asking questions, challenging assumptions, and never settling for good enough.
We hope you've learned something new and maybe gained a new appreciation for the complex and vital world of pipeline safety.
And remember, no matter who you are, whether you're an engineer, an operator, a regulator, or just someone who cares about safety, we all have a part to play.
So stay curious, stay engaged, and keep those conversations about pipeline safety going.
Until next time, stay safe.